Good morning. Yes, welcome to your second day of the fellowship. Hope it's going good so far. I hope everyone has their coffees ready and stuff like that because this might be quite a bit of information. So I'm going to try and go a little bit slower than my natural pace to make sure that we pick everything up. But yeah, this is the Unreal Gameplay Framework. My name's Martin Cousins. First off, I'm just gonna talk a little bit about the things that we're gonna cover. I'm aware that a lot of you are here primarily because you've not used Unreal very much before, or it might not be something you're familiar with at all. So we're going to talk a little bit about coming to Unreal from other engines. Then we're going to talk a little bit about kind of some things to bear in mind when coming to Unreal that maybe help you understand some of the workflows a little bit more easily and help you kind of come to terms with the way Unreal works. Then we're going to go into the kind of key components that make up the gameplay framework and what that actually means, as well as a couple of additional classes that are not strictly part of the gameplay framework that are just very good to be aware of when you're working on your projects. And lastly, we're going to do a small workshop, basically going through utilizing this setup, utilizing the classes that make up the gameplay framework, just to kind of introduce you to typical workflows within Unreal. One thing that I'll highlight is that you should already have access to all your box accounts and stuff like that. From the last fellowship, from the US fellowship to this one, we've made relatively substantial changes to the content I'm delivering on this course, as well as the files available to you. So I'm just going to say now that any files that may already be there might be slightly out of date. So just if you're looking at, if you've already downloaded some things from Box and it seems like I'm going really off script or like the files don't match up, that is probably going to be why. I think we'll get some files uploaded so that you guys can review this afterwards and so that you can kind of look at an example, look at the project that we've done. There'll be like an already finished version of it that you can kind of dig back through. But unfortunately, you're not going to be able to download something now to follow along, which is fine because the workshop wasn't really intended that you need to follow along with it. It's more kind of demonstrative. But yeah, it would have been good if you guys were able to crack that open at the same time, but it's ultimately it wasn't the primary intention anyway. So yes, my name's Martin Cousins. I'm a developer at White Paper Games. I've come from the same standpoint as a lot of you, I suspect, in that my first experience releasing a title was in Unity back in 2015. Obviously, engines have changed a lot since then. The ecosystem has changed a lot in 9 years or whatever that was. But I spent 3 years working on that title. So I have been through this exact experience where I wasn't educated in Unreal. I came to Unreal with pre-existing expectations about how things should work. So hopefully that gives me a slightly more uniquely similar experience to you guys. And hopefully that can help inform some of my thinking and makes my explanations a little bit more usable. So yeah, my first title was in Unity, but then since I have been working at White Paper Games, and I've been working on Unreal for about 10, just shy of 10 years now. I've shipped 3 titles, Ether 1, The Occupation, Daily Review. Ether 1, I wasn't there for the majority of, to be perfectly honest. I patched quite a little bit at the end. But we've also worked across some other IPs, working with other developers, working with companies such as Devolver Digital, Epic Games, and Raw Fury, working on some of their own either internal IP or other titles that they're kind of working on. So as well as those internal releases that we've done, I've also worked quite a lot across different platforms, across mobile, across consoles, helping support other developers. So jumping straight into the content, coming to Unreal from other engines. Like I said, I suspect this is going to be something that applies to a lot of you. You may be coming from your own internal engines that you've used, be that proprietary ones, or be that just other ones that are covered, maybe not here, or the obvious big contenders being Unity and Godot. In a lot of ways, there'll be a lot of commonalities that you'll see between Unreal and those pre-existing engines. And that can be a good thing because it can kind of familiarize you with some of these concepts, but can also be a little bit dangerous because it can mean you slightly miscomprehend the way things are working. So fundamentally, Unreal is built upon these core concepts of actors, which are the entities that you have in the level, components, which are things that you stitch into those entities to kind of add complexity, and then blueprint classes, which are like your carbon copies of those entities that you can then drag in multiple instances of it, right? And that maps relatively directly to act as being game objects in Unity or scenes in Godot. I'm gonna confess now, I've worked a lot in Unity. Godot is not something I have a huge amount of experience with, so anything I'm saying about Godot here is based off some research that I've done. But for anyone who's already worked in Godot, you may raise an eyebrow at some of my definitions here. But yeah, the idea of an entity in world that it represents like a single thing that would be a game object in Unity, a scene in Godot, and an actor in Unreal. Unreal also has this concept of components, which, the term is the same in Unity. They do function slightly differently, which we'll get into. But broadly, the idea is the same as these extra elements that you can kind of stitch into that single entity. And then that would be kind of mapped to nodes in Godot. Now, again, with Godot, when it comes to the what would in Unity would be called prefabs or Unreal would be called blueprint classes. I believe that's also scenes in Godot because it's very hierarchical. So you kind of have your levels are your prefabs. But again, that's relatively limited knowledge of Godot here. So you can absolutely pull me up on that if I'm getting that wrong. But yeah, generally blueprint classes and prefabs relatively one-to-one. They're the things that are actually in your content of your project that you can drag in multiple instances of it. So you have an orc enemy and you then spawn or drag in 10 orc enemies into your level, and it's the same thing, just printed out 10 times. So these are all concepts that you'll be relatively familiar with. Like I said, it's they're not a million miles away from each other, but there are subtle differences that do mean it's worth not just taking it as given that they're going to function in the same way. So jumping into kind of actors in Unreal, this is where you'll find quite a lot of the possible confusion. So some key things to highlight about actors that make them distinct. I'm going to talk primarily about Unity here because that's where a lot of my experience comes from. But I think this can broadly be applied to whatever engine you're coming from. Whereas in Unity and probably other engines, the entity actor in this case exists as something that you then stitch complexity into with the components. Components can be used to add complexity to actors in Unreal, but actors in Unreal actually have their own distinct logic. So what that means is two actors in Unreal with exactly the same components set up in exactly the same way can function entirely differently because the actor itself has code and logic on it. So you can get a very, very complex functionality in Unreal with very few components because you can do a lot of logic internally in that actor. So in blueprints in Unreal, that's done in what's called the event graph, which I've just highlighted here. Normally it would be its own window, but just to kind of get it all on one screen, I've just shrunk it down here slightly. But yes, typically in Unity, your game object doesn't have code on it. Any logic that game object gains only comes from components. Whereas in Unreal, the components can add in functionality, they can add in logic, but the actor itself has logic on it. As well as that, in I think a lot of other concepts, components are a little bit more like they're quite agnostic. There's no kind of like pre-existing functionality. In Unity, you have the transform component is a component in itself. So if you want something to have a transform, a location, rotation, scale, you add in the transform component, and that's what brings that functionality. Whereas in Unreal, there's a kind of split of types of components where you have scene components, which are a component that inherently has a transform, and then non-scene components. Those are actually organized separately in the hierarchy when you're viewing your blueprint. So you can see that here. We have our scene components arranged in this green box and your non-scene components arranged in this blue box. And what that means is you don't have a transform component. You have many different types of components that can have transforms. And they actually occur in a kind of hierarchical way, which you can kind of see here, where you can see we've got these little drop downs and we have indentations. This is kind of something that you would probably be relatively familiar with from 3D modeling packages or whatever, or scene graphs or anything like that, where essentially these things are childed to each other. So much in the same way you would have maybe bones in a skeletal rig or, other just within your modeling packages or anything like that. This means that these things all have a location, rotation, and scale, but each of those things is relative to the thing that they're attached to. So our cube is attached to our scene root, our point light is attached to our cube, and this some other scene component is attached to our scene root. So anything that is a in the hierarchy is a scene component. It has a location, rotation, and scale, and can kind of be moved around independently. And again, these things are all their locations, rotations, and scales are relative to the thing that they're attached to. So as you can see here, our point light, its location is 0077. That doesn't mean it's 77 centimeters from the origin of our world in world space. It means that it's 77 centimeters up from wherever the cube is, and the cube's position will be described relative to the scene root. And when we're talking about scene root, the kind of last thing to talk about is that as well as this hierarchy existing, components aren't completely all at the same conceptual level. There is a single component, which is referred to as the root component, which is essentially when you ask an actor where it is in world, what it will give you back is the location, rotation, and scale of the scene root. So our root component is an important thing. So this one at the top here, that is always where your root component is, and it will be the component that describes where your actor is in world. So that will be described in world space. You can have actors in C++ in Unreal. You can have actors without a root component, but in Blueprint, it's impossible. So every actor will have a root component, and that root component is what gives the location, rotation, and scale of the actor itself. And then everything else is just attached to that. So those are kind of three things that might seem a little bit strange and work differently from depending on where you're coming from, that are just kind of worth highlighting. So when coming to the engine and wanting to kind of understand some of its eccentricities, I think it's worth kind of going back to basics a little bit. So we'll talk through first how Epic themselves would describe the gameplay framework. So this is just copied straight from their own dev documentation. Unreal Engine's gameplay framework is a collection of classes that provides you with a modular foundation upon which to build your gameplay experience. You can pick and choose which elements are right for your game, knowing that these classes are designed to work with and complement one another. So that's to kind of slightly rephrase that. Essentially, these are the core classes that you can use and probably will use to make a game. They are more focused around games. If you're making something like an architectural visualization project or like a vehicle, if you're making like a BMW configurator or something like that, you might not necessarily leverage all of these classes. These are more geared towards games, but they're built in a way that you can pretty much use them to make any kind of game you can think of. So they're not so specific that it's going to bake you into making a first-person shooter or something like that. You could do an RTS with them, you could do a dating sim with them, whatever you like. So again, when coming to Unreal, it can probably feel in comparison to a lot of other engines, like it's got quite a lot of extra built-in pre-built architecture. And I think for some people who are used to something like Unity or Godot, which are a bit more like, we're going to give you kind of very bare skeleton of functionality. We're going to do rendering. We might do some physics and stuff like that. But ultimately, however you want to structure things is up to you. Unreal has a little bit more of a predefined idea of how you should be doing things. And that can be a little bit confusing, but it's also one of these things where if you kind of learn to work with that, that's kind of part of coming to terms with Unreal, is not trying to fight against it, trying to understand how it works. And some of that, you might have some questions about like, why is it this way? And I think if you go a little bit back to Unreal's origins and where the engine has come from, it can help you understand that thing a little bit. The other thing that I would say when you're kind of questioning some of these things possibly is to highlight that Epic has released a lot of titles with this. So it's been really, really hard battle tested. So this functionality is there, it works, and they've done a lot of different things with it. Just to take a small sample of these, obviously the name comes from Unreal the game released in 1998. That might be too old for some people to remember, but I certainly remember that coming out. And then moving on to Unreal Tournament in 1999, I think it's probably at Unreal Tournament that you can really see a lot of the structure is Unreal Engine now probably coming into place, which is not to say that you can only do, multiplayer first-person shooters with it, clearly. Gears of War was obviously a really notable entry. Infinity Blade, which is a mobile game. Fortnite, are very contemporarily. And obviously, they've released several other titles, but also hundreds of other games that you will have played have been made with Unreal, and they're not all first-person shooters. So very, very clearly, it's generic enough that you can do anything you want to do with it. A couple of things to bear in mind again about why there might seem like there's kind of more functionality in there than maybe you would need is that Unreal is built to be network ready out of the box, meaning it's very easy to make a game multiplayer in Unreal. Obviously, anytime you're doing something multiplayer, it adds in a lot of complexity. So I'm not going to say multiplayer games are trivial in Unreal. Multiplayer is never trivial because there's a lot of things you have to think about. But Unreal does a lot of foundational work for you to make it a lot easier than it might be in other engines. And what that means is some of the functionality is not stuff that you'll need all of the time. If you're not doing a multiplayer game, some of this stuff won't apply to you, and that's fine. But it's there if you ever try to turn your game into a multiplayer game, or if you try and make another game that is multiplayer. Yeah, again, thinking about where Unreal came from, thinking about that kind of history, some of this structure can make a little bit more sense, right? Like if we think back to Unreal Tournament, you have a game there where you have a broad structure, it's a first-person shooter, but you might possess multiple characters throughout your play session. Your character might die, and then you possess another one. You might jump into a vehicle and drive around a little bit. But you have this concept of yourself as a player distinct from those things that get destroyed, right? You have a score, you have how you're doing on your kill death ratio and things like that. So you need the notion of a player distinct from the thing that you're currently playing as, and you might play as several things across one game session. And then from one level to the next, there might be the idea of the level as the kind of geometry where you've got a jump pad here, and this is where a weapon spawns, and this is where a bot might spawn. But distinct from that, you might have a set of rules that is like, this is the capture the flag game mode in this level space, and this is the domination game mode in this level space. So once you kind of begin to understand that those were notions that came about early in Unreal's conception, you can understand where some of the terminology for these classes maybe came about, and also the kind of reason that these classes exist. Again, that is not to say that these are only geared towards that, but that's certainly where they've come from. But the functionality they provide is absolutely generic enough that you can do anything with it. And yeah, again, coming back to that thing about the network play, not all of the architecture that Unreal provides is always going to be stuff that you need to use. So you're not doing something wrong if you're not using every one of these classes. Some of these classes just won't apply to the stuff you're doing, and that's absolutely fine. And just being aware of that can be important. But coming back to that point I made on the last slide, understanding the systems that do apply is very important. And the kind of key takeaway I would say is don't try and reinvent the wheel. Like you probably can completely start from scratch and do everything, but Unreal is going to be doing a lot of stuff for you that makes things a lot easier. And it's, several hundred incredibly talented developers who are making all this functionality and making amazing editor features for it. So it's really easy to edit. So a lot of the time, what I would encourage you doing is rather than being like, I'm going to make this new feature, just see if it's something that Unreal already supports, because the likelihood is it's going to work better in the long term with Unreal. It's going to have awesome editor features that make it much easier to use, and it's going to be supported. You're not going to have to then worry about keeping that up to date. That's going to be kind of Epic is doing that for you. So don't fight against the engine, work with what it's already got, what it's already providing to you. So that's a lot of initial information, but let's actually get into what makes the gameplay framework. So we're going to talk about the classes, and then, like I said, a couple of other classes that aren't strictly the gameplay framework, but are really relevant. So as Unreal defines it, as Epic defines it in their own documentation, the gameplay framework is made up of this set of classes. We have pawn, character, controller, player controller, game mode, game instance, game state, player state, HUD, and camera. The I've highlighted those six at the top in pink because I think those are like the really key ones that you need to be aware of. There are slight caveats I would apply to the last four, game state, player state, HUD, and camera, that don't mean that it's not to say that you should ignore them, but just I personally, from the way I kind of view it, don't interpret those as either such key components or they're kind of just things to be aware of when we're talking about them. So going through them individually. Pawn is the base class for any actor that can be controlled, and that is controlled by a player or an AI. If you think about the role of a pawn as the thing that provides the capabilities, right? So if I have a character, that character can jump, they can pick up a gun, they can shoot. That might change from when I'm playing as a guy running around with two legs versus when I'm driving a car. So both a car and the guy are pawns, but they provide the functionality for, what they do. When I press W with the guy, he runs forward. When I press W with the car, it provides torque on my back wheels and, it might slip depending on what surface it's on or whatever. So you see that the functionality they provide is very, very different from thing to thing. So pawn is this generic thing that is anything that can be controlled either by a human being or an AI. Character is essentially just a specialized version of pawn. It's not surprising that the vast majority of games have you playing as a vaguely 6 foot thing that can run and jump, probably has legs, and has some kind of visual representation and collision, right? That's the vast majority of most characters in most games. So Epic has essentially just done a shortcut for you and provided a lot of that functionality. So character inherits from pawn. That's inherit being a term that people will probably be familiar with from like coding or anything like that. It just means it brings in all the functionality of pawn and adds in some extra. So it's essentially just a pawn that has a collision, has a mesh that you can visually see, has some movement capabilities for running, jumping, also flying and swimming, which obviously aren't so commonly used. I think it can crouch as well. Um, and yeah, I think that's it. It used to automatically come in with a camera as well, but I don't think it does anymore. Um, yeah, controller is the other side of this relationship between the thing that is getting controlled, which is our pawn. Controller is the thing that does the controlling. So we talked before, right at the beginning, about actors being entities within our level. Anytime there is an actor in the level, you can open up your level browser and actually see all the actors in your level. Controllers are actually actors, so they do exist in your level. They get spawned in, but they're non-physical. They don't have a collision. They technically have a location and rotation. Those things aren't super important. The rotation does have a relevance. But the controller's key role is to possess, to control a pawn. Um, Controllers can be controlled by humans or by AI. So it's kind of the root thing. And then there is a specialized one for a player controller, which we'll get onto into a second. Um, Typically, controllers are spawned at runtime. You wouldn't normally drag a controller into the level when you're editing it. There's kind of no need for that. They get spawned by Unreal's kind of baked in functionality. And yeah, they represent the thing that is doing the controlling. So as a player, it represents me. As an AI, it represents the kind of conceptual entity that is responsible for controlling that enemy. Um, like I said, the location isn't super relevant. The controller's rotation is does mean something. There is functionality when you're editing Unreal to get a control rotation. It normally represents, as a player, it normally represents the intent direction, right? So if you're in first person, your controller rotation tends to represent the direction you're looking in. That's not 100% of the time, but I just wanted to highlight that its location, rotation, scale aren't completely irrelevant. Its rotation is actually used in code at some points. The other thing that's kind of important to highlight is that pawns don't need controllers. A pawn can exist without a controller if it's just doing nothing, basically. If it's just sitting there, not moving, well, it technically could still move around, but if no one is doing anything with it, it doesn't need a controller. Um, and another situation that can happen is that a controller can outlive its pawn because if an orc gets shot in the head, the thing controlling it might still be around, but the orc is now gone. So just kind of they are distinct from each other, but they are tightly related at the same time. So in the same way that character was a specialization of pawn, Player controller is a specialization of controller, which essentially is the kind of controller that specifically represents a human player. And the player controller essentially represents the interface between me as an actual human interacting with the game and then the thing that I'm controlling, right? Um, it's not specifically highlighted as part of the gameplay framework, but I think it's worth talking about it to highlight that it is this other thing, right? Player controllers are controllers. Not all controllers are player controllers, right? Only the ones that are used by human players. Um, and yeah, they essentially represent a human player locally in the game. And something that it's really there to centralize things that only a human would care about. So the direction I'm looking in, it essentially handles my camera as a player, and it handles my input. I just want to highlight that both of those systems are under the hood. They're handled in kind of their own places. So there's a camera manager that does your camera, and there's an input system that handles your input. But those both end up funneled into the player controller as a way to expose it to you as a developer to interact with. So game mode is essentially a class that exists. There is one per level, and they give you an opportunity to specify things that might be level wide, but you might want to replicate them multiple times. So if you think about like a capture the flag game mode, right? Capture the flag isn't one level, it's a conceptual thing that can be used in multiple levels. But it exists for the entire duration of that level. That's kind of what game modes are there to do. Game modes are actors. They do exist in your level, not when you're editing it, but if you hit play, you'll be able to open up your game, your world outliner, your kind of view of everything that's in the level, and you'll actually see your game mode get spawned in. There is only ever one game mode per level. You can't well, if you tried to delete the game mode, something would probably go very wrong, so don't do that. I'm not even sure if you could do that. But typically, the most common interactions that you have with the game mode are for specifying by default what player controller is used in this level, what pawn is spawned for a player in this level. We'll go into that a little bit later when we're doing the workshop, but that's like first and foremost, that's the most common thing that you would interact with the game mode. The game mode specifies what is the standard thing that I should spawn for players in this level, and what is the standard controller that players should use in this level. And that's actually interacted with via the world settings, which again is a class that we'll get onto in a little bit, but it's essentially just there to define some things about the level. The game instance is a little bit like the game mode, but rather than occurring one per level, whereas, in level 0, you might have one game mode, and level 2, you might have a different game mode, but you can reuse the same one for multiple levels if you want. The game instance is just one across your entire project. So you open up, as soon as you boot up that game, your game instance starts, and the same instance of that game instance will last all the way until you close that program. So it's a little bit like, I don't want to confuse the term for anyone who's already a programmer, but it's a little bit like a singleton. It's this one thing that lasts across the entire project. So as you go from level 0 to level 1 to level 2 or whatever, you still have the same game instance will persist across all of those things. That means it's a place that you can store and access information that will persist between maps. Whereas in Unity, it's relatively trivial to have information that you just say, I want this thing to not get deleted when I load from level 1 to level 2. That's not really set up the same way in Unreal. So the game instance is one thing that you can leverage to say, this thing will definitely last between level 0 and level 1 and level 2 and forever as long as the game is running. So anytime you're thinking about information you need to persist between them, obviously you could do it through save files, but the game instance is another way of doing that. Yeah, it lives for the duration of the program. You can only have one game instance for your project because it starts right at the beginning of when you boot up your program, and it lasts right until you close it. You can't swap it out. You can't delete it. You can't replace it. You can't change it. So in your project settings, you choose the game instance that is used for this program, and that is it. You can't change that. Obviously, at editor time, you can change that, but once you're within your game, it will only ever have one. Yeah. So game state, this is where we start talking about the things that have slight caveats. The kind of TLDR is that game state is really the same as game mode, but it's particularly intended for multiplayer functionality. So it kind of performs the same function as game mode, but whereas if I'm in a multiplayer game and it's me and four friends, then each of us will have our own game mode that basically don't listen to each other and none of that information is communicated. Game state is inherently replicated over the network so that any information that you kind of want shared between players, so you want game mode might have something like my respawn location stored in it because none of the other players care about where I'm going to respawn. But game state might have something like our score table because, obviously that's information that everyone needs to know about all the time. So yeah, essentially the same thing as game mode, but for multiplayer, which is why it's kind of a caveat because if you're not making a multiplayer game, you basically never need to interact with game state. Player state is essentially the same thing. It's like the player controller, but specifically for multiplayer. So on a multiplayer game, there might be one local player controller per PC, but if I'm playing with four friends, all of us will have five player states in our game because it's one to represent us and one to represent each of my friends and all their kind of player information that needs to be replicated across the server. So again, that might be I don't know. If your health wasn't tied to the thing you're playing as, if it's like your health is this consistent thing between the things that you're controlling, maybe you would do that on the player state, and that way it's replicated over the network, and everyone knows what every player's health is, for example. Yep. So essentially, player state is just the multiplayer version of the player controller. HUD is something that the Epic highlights as part of the gameplay framework. The reason that I've kind of put a caveat on it is there is obviously the notion of a HUD that we're used to, right? Like the term gets used a lot. It just means the stuff on your UI. In Unreal, it is a very specific class. There is a HUD class, and it provides certain functionality to display things on your UI. The kind of primary reason I would caveat it is that HUD is a very easy, simple way to get things on your user interface. But once you start having things a lot more modular and quite a lot more complex, and maybe with lots of animations going on, HUD be begin to hit the limitations of what the actual HUD class itself can do. And typically, a lot of games would start using a kind of more recent notion. I say recent, it's probably over 5 or 6 years old now, called widgets and UMG. And that's typically a lot of game UI that you see in using Unreal is more likely to be done using widgets now. So HUD is a very simple, quick way to get some UI on screen, but it's not necessarily the only tool in your box. And certainly once you're trying to do more complex stuff, you would probably start to move away from it. You can use both widgets and HUD, but I just wanted to highlight that HUD isn't the be all and end all of UI. It's actually probably the minority. And lastly, camera. The only reason I wanted to kind of like caveat this is that obviously it's not related just to games, right? Like if you're doing a architectural visualization, you probably still have a camera. Cameras are probably used in anything Unreal because if you're seeing something, then it's likely you might want a camera. The kind of on the flip side of that, you actually don't need a camera to play a game. If you put a pawn in the level and you control that pawn, Unreal will just assume it will look for a camera, and if it can't find one, it will just assume you want the player's eyes to be kind of in the center of that pawn that you're controlling. So you don't even need to use a camera. What cameras do is give you more control over that view. It means you can define things like your aspect ratio, your zoom, things like that. And there is a kind of a second kind of camera, which is more geared towards things like film. So it's called a cinematic camera, and it gives you this extra functionality of things like you have field of view anyway, but you have things like your I forget all the terms now, but like you have it more baked in depth of field effects. You have your lens distance. I forget the actual official term for that. You have control over your aperture. These are things that people who make films and work with real physical cameras, these are terms that they would be used to. And it's that, so the cinematic camera kind of exists to make it a bit simpler for them to use, but it also comes with certain nice extra cinematic effects, things like depth of field and stuff like that, and focus. The other something kind of important to highlight about cameras is it's not one camera per pawn. If you look at the vehicle template that it comes in the template projects that you guys have, but also just a lot of the example templates, a pawn that you're controlling might have more than one camera on it. But then it's up to you as a developer to control which camera is being used. A really typical example would be that a car might have a camera behind it like this, another camera that's a little bit closer for that view, and then a camera in front if you want to do your reverse view. Obviously, you could also just have one camera and move that around. So that's a kind of a stylistic decision for yourselves. But yeah, I just wanted to highlight that you're not locked into one camera per thing. Things can have multiple cameras. It would then just require additional work from yourselves to be like only have one of these cameras active at one time so that I know which camera my player is going to view through. Um, the other thing to highlight kind of here is that whilst the default functionality of Unreal is when you start controlling a pawn, when you start possessing a pawn, it puts the game view into that pawn. Your game view can be entirely distinct from that pawn. So the default is it looks through that pawn's eyes, but then you can then say, actually, look through this camera over here. For something like an RTS, perhaps that makes sense, or any kind of game where you have maybe something like Super Smash Brothers, right, where all have one shared camera. Your camera doesn't have to in any way be linked to the thing that you're controlling, but that is just the default implementation. And I bring that up at the same time as cameras because it's very likely then you would want to be doing that with a camera. So that's all the kind of key classes that Epic themselves define as part of the gameplay framework. It's a lot of information very quickly, but we'll go into our actual workshop to kind of dig into that a little bit more. Two
And
class.
just before you hop on and continue, just for
Mhm.
the sake of answering a few questions that I think need a
Yeah,
little bit of
absolutely.
nuance.
Mhm.
There's a few questions here. So one of them is that the game instance sounds like a singleton prefab with a don't destroy unload
Mm.
from Unity. Um, and I guess the question is, if we can only have one, can we create childs for it?
So technically, you can make children of the game instance, and you can and should make a child class of the game instance. But that might be a terminology question because yeah, or a semantic question. You can, like I said, you can only ever have one game instance. Even if you made 10 child classes of your game instance, only one of those could ever be used for your project. So there's basically no use of having more than one class that represents your game instance. Because you have to choose a single class to be your game instance, and that will always be the game instance for your project. You can obviously change that at editor time. You can edit the different one, but throughout a play session, it will only ever be one game instance, and you can't change that. So
Can you create subsystems within that?
yeah, there is a notion of something called a game instance subsystem. So semantically, yes, you can have game instance subsystems, and they would last throughout the duration of your project as well. So you can stitch in additional functionality, and then maybe if you move on to a different project and you want some of that same functionality, you could copy paste that subsystem blueprint across. I'm not 100% certain if you can make game instance subsystems in Blueprint though, because whenever I've done that through C++. So it's worth looking into. There is a notion called subsystems, and there is a game instance subsystem, which would also last throughout the duration of your application. I'm just not 100% certain you can do those in Blueprint. Maybe you can, and we can absolutely look into that when we're in the workshop. But yeah, I just wouldn't want you to quote me on that. Yeah, again, one thing I would highlight when you use the term singleton. I did say singleton because it's a little bit like one, but Unreal does actually allow you to specify a separate game singleton class. And a little bit like the game instance, you can only have one of those per project. But so you do have, out of the box, you do have two opportunities for something that will last across your entire project. You have your game singleton and your game instance. But singletons are a lot more complex, and a lot of people, certainly when you're doing simpler projects, you just don't need them. So I wouldn't get too much into detail about that. But yeah, it is not. It probably functions like a singleton, but it's not strictly one. And there is additionally a game singleton class that you can specify in the project settings. Um, yeah, hopefully that
Um,
answers that.
yeah. So the next question, I think it is this, but essentially, what's the entry point of the Bootstrap application? Is it always the game instance?
Yeah, that's a complex flow that I'm not sure I would be confident to answer. What I can say is there's a very good video by a guy called Alex Forsyth who actually goes very in depth into the boot process of Unreal, like all of the functions it calls from the moment you double click on your executable. So I would direct you to look at that. That gets very technical and codey. So if you're not a programmer, it'll probably like melt your brain. But for people who are programmers who are very interested in the real nuts and bolts of exactly what it is doing, I would direct you towards his YouTube. There is actually a reference to another of his videos at the end of this presentation, which just talks about the differences between basically a little bit of what I've talked about here about Unity, Unreal, and Godot. It's not that video that I'm talking about. It's another one on his channel, but I can either link that or you would very easily find it. It's just I can't remember the name of it, but it's essentially about the boot flow of Unreal. But yeah, I couldn't answer that with certainty.
Someone's actually pasted this already, that video,
There
so
you go.
I'll put it in there as a reply as well. So Salomon asks, does the game state contain all information of the current state? So can I simply say, for example, serialize your game state to create a save game file?
The game state has whatever you want in it. So it's the thing that defines what the game state is really is when it gets spawned, how long it lasts, and the fact that it will be replicated for you across every one of the players, across every one of the um, multiple players of your multiplayer game. So what is in the game state is up to you. You can have entire other classes that are none of these that we've just talked about, where you have all your game state, but it's just in a multiplayer game. It might make sense to store your game state in a particular place if you want it replicated. Replicated being a term for essentially copied across your network in a multiplayer game for anyone who's not familiar with that term. Um, so you don't have to put things in your game state, and there's no like strict requirement. You could make an entirely separate blueprint, make that blueprint replicated, and do it through that. It's just that game state is doing a lot of that stuff for you. So yeah, the game state isn't doing anything magic. It's not gathering up any extra information. It's just a class. The only kind of automatic magic things about it are you specify your game state for that level, and your game state will get spawned automatically when that level starts. And then it's just much easier to replicate information across in that class. There is still manual setup to replicate information across. You can't just add a variable. You do need to tick a couple of things, and you still need to handle that information coming from one client to another. Sorry, getting slightly into kind of in the weeds with networking terms here. Um, there's nothing automatic about it. It's just a simple place, and it's a very common thing that you need with games. So that's kind of why the class already exists. Hopefully that answers that question.
Okay, oh, there's a follow-up of that.
Hmm.
If the data is replicated over the network, it pretty much knows about all information that would be needed for a save game, though, right?
Yeah, I suppose so. You, yeah, you would need to set up a save file in Unreal using Unreal's functionality. You actually need a separate class called a save game class. So there would be a step of copying that data into your save game class. If you wanted to leverage Unreal Save System, which is really, really easy. So I would encourage you to do that. So there would probably still be an additional step because your game state couldn't be both. It doesn't do multiple inheritance, right? So it can't be both a game state and a save file. So there would still be a step of copying the things that you want to save into your save file class, unfortunately. But that wouldn't be super hard. So yeah, I suppose in a way it could be, but you would unfortunately need a save game class as well.
Uh, I think that's all of the ones that I think we want to ask for now. The rest, I think we're able to cover ourselves.
Okay, amazing.
So I think you can go for it, unless someone really wants to get uh da, 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 da.
I can keep going and we can come back if any questions are still
Well,
coming in.
someone's asking for a 5-minute toilet break. If you think we can do that.
Yeah, I
I
think
think it could be it could be a
yeah,
good thing
okay.
since
Yeah, all
the
right.
hour
Yeah,
mark.
5 minute toilet break and a 5 minute decompress after like the absolute
It's a
wad
lot,
of
yeah.
information that I've just thrown at people. Yeah, absolutely. Yeah, let's give it a couple of minutes.
There is one other question, Martin, which
Mhm.
again I think we can probably answer, uh, but I think getting your nuance will be really handy. But essentially, and this is the age-old question, right? But like, when do you think Blueprint should be used instead of C++? plus plus?
Yeah,
And
that's
I
like
guess vice
probably
versa.
the third most common question when going to Unreal.
Yeah.
So a short answer is that you should probably always use both.
Yep.
Um, it's more the kind of and the these things will differ from developer to developer, and people prefer certain things. For example, it sounds like a pretty trivial thing, but I really find having to switch my right hand from keyboard to mouse, I feel like that slows me down a lot, which drives me away from Blueprints because Blueprints requires a lot of hand switching. It seems like a stupid thing, but I think it's worth thinking about for people who are like, your workflow is your workflow, right? And how you find you'll work out how you work best. So things like that can inform that question as well. But the kind of hard facts about how each of these things work also make quite a big difference. So with C++, over the past few years, Unreal have begun, they used to have a concept called hot reloading, which has now become, I think they acquired some third-party software and internalized it, and it's now become a concept called live coding, which means you make some code changes, and there's probably about I don't want to put a hard statistic on it, but about 80% coverage of about 80% of the code changes that you make would probably come up in live coding. There are certain things that you could do that if you compiled through live coding, it wouldn't catch those or something would go weird and wrong, and it's probably a bit dangerous. But for the most part, if you make some code changes, you can press Control Alt F11 and it will basically recompile all your scripts and your game will now function with those new changes that you made in code. That being said, even in the best case scenario, live coding probably takes at best like 15 seconds and at worst can be 10 minutes. So it can be a fast-ish iteration to an incredibly slow one, depending on the size of your project and the size of your code base. Whereas with Blueprints, to make a code change, you press compile, and at worst, I think it takes like a really intense case would be 2 seconds, but most of the time it's like instant. Um, so you can see instantly a difference in iteration time there, right? The typical thing tends to be that you would probably do most of your prototyping in Blueprints, unless there's functionality that you just can't access, which is another thing to bear in mind, is Blueprints can't access 100% of Unreal when it comes to kind of more fundamental foundational systems and mucking around with things like memory addresses and unlocking render threads and stuff like that. That can only be done in C++ plus plus because I guess they didn't want to trust designers with that, because they didn't want them to set things on fire or something. I don't know. Over time, is exposing more and more stuff to Blueprints, but I think whenever they're doing that, they're probably thinking at the same time, we need to make sure this is user friendly. Whereas with C++, plus plus, it's kind of like, as programmers, they don't need things user friendly. They can just work it out. Um, so yeah, there's also a level of like you just can't do everything in Blueprints, but for the things that you can do, which when you're prototyping, that you probably get pretty far. The general thing would be probably do that in Blueprints because your iteration time is so much quicker. And then when it comes to referencing content, that's the other thing I'd be bearing in mind is that there's a couple of advantages and disadvantages with Blueprints. For a start, whenever you want to like just grab a texture or a mesh or a sound effect in Blueprints, you've got to drop down and you can see all your sounds, right? Whereas in C++, plus plus, if you want to do that, for a start, you have to like call up your audio guy or browse through your content browser to find it, then go back to code and type in text the location of that file. And then if someone ever moves that file, your code is broken now. Whereas if someone moves that file in Blueprint, Blueprint will say, hey, this thing is referencing that content. So we're going to create a redirector. And then your system isn't broken anymore. It's just kind of doing it's going here, finding that it's not there, but there's a file there that says, oh, instead this occurs over here. And it inherently understands that things are referencing content. So it comes with that advantage. The disadvantage is that there's a concept of references become quite important in blueprints. So when you're using blueprints, the things that you're referencing might be loaded into memory all of the time that they're being referenced, which just means that it's very easy to mistakenly make your game take up like 500 megabytes of memory from the first second because the character references this thing, which references this thing, which references this library of textures. Um, and so that's something you kind of need to be careful with blueprints. So the kind of TLDR there is it depends, but you kind of gain and lose things both ways. But kind of in the simplest way, prototype in blueprints, and when you're referencing content, probably do it in blueprints. But the th thing to be aware of there is the kind of cost that references can have, and there are ways around that, but that gets a little bit complex. So that answering that one question took us the 5 minutes of our toilet break, I think. So are we good to keep going, or are we
We've got
waiting for some
another
people to come
question
back?
that I think you should answer again.
Yep. Okay.
Um, so this was, I think, in relation when we were talking about game instance
hmm
and things like that. But essentially, does this all mean that all the logic, like the controllers, should be dropped in the scene, and if there's no way to, and there's there not being a way to do that? So basically, this person who's a Unity user says
hmm
in Unity you can have mono-behavioral classes that
hmm
work on the life cycle of the scene, but
hmm
also non-monobehavioral classes, which are pure C++ classes. Is that possible in
Mm.
Unreal? And
Well,
if not, how do you test those?
how do you test those? So what I would say, I'm probably misinterpreting the question, but you Unreal is just C++ with some stuff on top. So anything you can do in C++, you can do in Unreal. Unreal is obviously ha adds in memory management on top, but you can basically remove yourself from that ecosystem if you're a programmer and kind of just use pure C++ functionality. So you can just do um, I've not tried it myself, but you can probably just make a static C++ class, and that would probably Unreal probably isn't going to tell you off for that. You would just have to make sure that you clean that up yourself. But it's not really intended. And again, the more unless you're doing something very complex, I would encourage you back to that point I made earlier about like try and do things more the Unreal way. So depending on what you need out of that functionality, maybe there's just no other way around it. But what we quite often do at White Paper is we would have like manager classes, which is like an actor that exists in the world, and we access it. Apologies, this is going to get kind of C++y for anyone who's not a programmer, but you access it through a singleton, and all it will do is like if that singleton instance doesn't exist, it will spawn the actor in. So then you've got the manager for that level because you needed it. It's just lazy loading it in basically. But that actor will automatically get cleaned up when you move to the next level because all actors get destroyed and cleaned up when you change level. And then your singleton is null again. And then the next time you access it, it just respawns what that new singleton instance in that level. So it's a really nice way to make manager classes that you don't have to worry about because you know they get cleaned up and you know they exist within that level, meaning they inherently have access to all the things that are within that level. Um, so that wasn't a direct answer to the question, but yeah, I mean, coming back to it, you probably can do anything you want to with the just raw C++ stuff. That can be a bit risky, but I suppose I'd need to see an example of what you actually are trying to do to maybe give you a better answer.
I think ultimately, and this is more one for like programmers in general, is that um yeah, work with the engine and not against it. Would be my biggest bit of advice when trying to learn Unreal.
Yeah,
Is
hard-learned advice.
yeah, it's essentially Unreal has all of this battle tested, and yes, it might be that it feels a little bit contrived to reach a particular goal that you're trying to do when you're used to doing it in another way. But the benefits of doing it the way that the engine actually wants you to do it will be very, very big and long term.
Yeah,
So it's just a heads up on all of that.
yeah. Yeah, and worst and most extreme case, you can edit the engine is one of the beautiful things about it being
Yes.
open source. So if you have some very bespoke case that the engine just can't do, you can just add that functionality into the engine. It's one of the really nice things about it being open source.
Yep.
Okay, we good to
Uh,
keep going?
yeah, I
Or
think we are
another
good to
question?
keep going.
Okay.
Because we need to.
Yeah, we definitely
So
do.
let's
Yeah,
get going.
I love answering questions, don't get me wrong, but yeah, there is content that we need to get
But
through.
just a heads up as well for everyone. If for whatever reason, one of the TAs can't answer your question. Again, I'm being very cautious of I know some of the answers to these, but I want to make sure that we get the nuance that Martin can bring that I can't.
Mhm.
So we can always get Martin on Slack afterwards as well
Yep.
to answer some of these. I'll just start pinging him in the ones that I think
Yep.
could use Martin's input if we can't get to them in the talk. So yeah,
Yeah,
just a
absolutely.
heads up.
Mhm.
Uh,
So yeah, we this is the classes we've just covered were the ones that Unreal highlights as the kind of key components of the gameplay framework class. So the next two I'm going to talk about, these aren't part of the gameplay framework, but they're just really fundamental, important classes to be aware of. One of them you're kind of secretly interacting with, and you just might not know it, and the other one is the level blueprint, which we'll talk about in a second. So first off is the world settings. This is just a class that you don't necessarily know you're using, but you actually are. So the world settings is basically when you create a level in Unreal, the thing you can choose what game mode this level uses. When you're doing that, when you're saying what uses the game mode, that is the world settings. The world settings is kind of a class that is baked into a level that says, okay, what are the settings for this level? Hence the name world settings. Um, you can actually go and access it in the details panel. There's a drop down window for world settings, and there's a couple of things there, like there's some lighting stuff for how this level should be lit by default. I think there's some settings about when you create this level, does it have some default offset? Considering things like maybe possibly streaming this section of level in, you can edit it as though it's 000, but then in the world settings, you can say, actually, this level occurs at 2000 because it's always streamed in there in the level. But also the world settings is what controls what game mode is used for this level. So more commonly, the way you would interact with it is in this drop down at the top, which I'll quickly, in fact, I'll just very quickly switch over here. You would see you do this drop down to specify your game mode. You're now this world override is changing the world settings. So you're now interacting the world settings by choosing the game mode that this level uses. So that's the way you would most commonly interact with it. You just wouldn't necessarily realize. Yeah, so just it's good to be aware that it's there. It is actually an actor, but unlike most of the others, when you play the level, you won't see it in your world outliner. It's kind of invisible and secret because you don't really need to access it as though it were an actor. But it's just what is true of this is true of all actors is that they get spawned in the level. When that level is gone, when you change level, when it's deleted, it automatically all actors are deleted. And so they probably did it for that reason, I'm guessing, is that it just automatically needs to be cleaned up. So why not make it an actor so it automatically gets cleaned up? The second class to be aware of, and this is much more likely that you guys will be leveraging this quite heavily, is the level blueprint. So the level blueprint is a specialized blueprint for that term. Who anyone who's not familiar with that, it's again a thing that we see in the content browser. It's essentially the way that we can code things in a non C++y written way. It's through nodes. And so every level has a kind of script baked into it, which is our level blueprint, meaning that it's very easy to do level bespoke code in this. They're going to do that kind of Uncle Ben Spider-Man moment of with great power comes great responsibility, because what the level blueprint lets you do is very easily reference any actor that is in that level. Rather than having to do some kind of complex thing where you make a public variable, you drag something in, and you specify it that way, the level blueprint, you can basically just press a shortcut, and you can get access instantaneously to any actor that exists in that level. Obviously, those actors would need to exist at editor time because there's no way you can't reference something in the future. But it just makes it very, very easy to set up level specific code. Like, I've entered this trigger, make this door open and spawn in 10 enemies. But the kind of danger of the level blueprint is it can drive you towards highly bespoke code. And the example I just gave, right? Probably what you should be doing instead is making some kind of enemy wave spawning system that you can reuse multiple times in multiple places. So whilst it does let you do that, it comes with the risk that you end up making highly bespoke code that actually, if you made it generic, it would be way quicker in the long run and way more, less bug prone. So it gives you a lot of power, but you just need to be aware of the kind of like workflow shortcomings if you end up leaning on it too heavily. But what it lets you do is, again, very specific level code very easily. And for things like entering a trigger and playing a cinematic or something like that that would only ever happen in this level, it's really great for implementing that stuff and not having to create a class that only exists for this level. So kind of why are you making it? Um, yeah, I think that's kind of everything to say about those. So to kind of re-summarize everything we just talked about, these kind of key classes that we just went over, I thought I would give an example of a game timeline to just to kind of like reseat this information in your brain to kind of like reinforce it a little bit before we get into our workshop. So I'm just going to go through a little ti example timeline of a pretend game that we're making. So if we think of our whole application duration, we've got our game instance there, right? If I called my game instance BP game instance Bob and I assign that in the project settings, that Bob game instance will last throughout my whole duration of my game. If I open up my kind of intro level, then a game mode and game state will get spawned with that, and those will only last as long as that level lasts. It's worth highlighting as well. I think the menu stands as a really good example of the distinction of a game mode because it's very easy to ask the question like, oh, why wouldn't I just use one game mode? Where would I use game mode A instead of game mode B? I think the menu presents a really good example of that, where in your menu, typically you don't want the player to have a character, right? Obviously, there will be examples of like, oh, I played this game where you play the menu and it goes straight into you playing controlling this character, or in the menu, I am controlling a character and that's how I choose options. So obviously there'll be examples where this isn't the case. But typically in your menu, the character that you're playing as basically does nothing because they're just some empty vessel that doesn't move, doesn't have collision, doesn't do anything. And then all you do is control a UI on top of that. So a menu, I think, it stands as a really good example of you would probably have a menu game mode, and the templates that you guys will be working with does have this, and that menu game mode probably has plugged into it some nothing player controller and some nothing player character, just to be like, don't do anything in the game menu. I just want UI to do all the controlling in the game menu. Whereas, in a level, then your player controller would have all this more advanced functionality, and the pawn you're playing as would be able to attack things and jump around and stuff like that. So we have our menu level, and the same as the game mode, our game mode will instantly spawn our player controller and our player state, and they will last for the duration of the level. And bearing in mind that this is a menu level, our pawn will get spawned at the same time by our game mode as well, and there's no reason that we would destroy that pawn early, so our pawn gets spawned at the beginning of the level and deleted at the end of it, right? That's the kind of standard flow. So if we extend that to like, if we move on a level, we've moved on from our menu to our first level, you can see we use a different game mode now because we're now in the dungeon level. And so we have a different game mode, and that game mode specifies that the player controller that we should be using is our dungeon crawler player controller. And if we were doing a multiplayer one, we would have a player state there as well and a game state. And also the pawn that the character uses would be this player hero pawn that can run around and jump and attack and stuff like that. And thankfully, we don't die in the level, so our player hero lasts for the entire duration of the level, as does our player controller. But if we come across some enemy that gets spawned in, that enemy gets spawned in and a controller gets created for it. And then after like a minute of fighting this enemy, I kill it. And you can see that our pawn gets destroyed. But by default, unless I specify to do this, the controller for that monster would naturally last to the end of the level as well. So that's just a kind of example. That's just showing you, again, controllers are distinct. They're linked with pawns, but they are distinct from them. So they don't inherently have the same lifetime. And if we kind of take that one step further and we go from our dungeon level to our town planning level, for anyone who's wondering what game I'm building up in my head, this is very clearly Dark Cloud from like 2001 or something like that. So you're in the dungeon, you're going killing monsters, then you go back and you build your base up in this second level. So there you play the game in a slightly different way, in which case we have a town planning game mode where we add in some different functionality and our player controller needs to do different things. And maybe we have the same player character by default, but then I can go up to this menu, this town planning station, and I temporarily create and possess a different pawn that puts me in like this top-down view where I can place buildings and stuff like that. And then when I'm done with that, I quit, and that pawn gets deleted then, and I go back to possessing my player character. And I run around a bit, and I go to like my wardrobe, and I change character because I was playing as a warrior and now I'm playing as a wizard. And so that wizard character gets spawned in, and after I confirm that I do want to play as the wizard now, it deletes my warrior character, and now I'm possessing the wizard character. So you can see like here was my warrior character until I chose to swap, and my wizard was spawned in a little bit early so I could see him. And then when I chose to confirm, I now this player controller is now possessing this wizard. And just to kind of highlight this as an example, here's some innkeeper in my town that like has no controller at all because pawns don't need controllers. It's just if you want them to have some kind of intent, um, it makes sense to do that through a controller. So, but this innkeeper is basically just a menu with a 3D model on it. So it doesn't need a AI controller. It doesn't need no one, the player can't play as it. So it has no controller at all. It's just a pawn that's sat there in the level. Um, so yeah, that's just to kind of like sit those concepts that we've already talked about just in an actual example of a game. Hopefully that's not more confusing. That's clarified a few things, but absolutely we can come back to that if anyone has any questions about that. The last thing I wanted to talk about is this already came up in the questions a little bit, but you might now have questions about like, okay, so I understand these things, but how do I get hold of them? Where do I put all of these variables? And what's the kind of like a good framework for being like, okay, I've got this thing. Where do I put this? Does this go in the player controller? Does it go in the game mode? If you want to kind of like go a bit more into depth into these things, I have made a second presentation that goes into that. I'm not going to be presenting it today, but it's just like some material to dig through. There's obviously lots of resources about this online as well. But this should be uploaded to Box already. If not, it will be coming very shortly. So feel free to kind of like ping if it's not appearing. But I think it's just called Gameplay Framework Addendum Accessing Data. So just for anyone who's a bit like, oh, where does this variable go? How do I know where to put this? That just goes a little bit more in depth about those things. So going on to the workshop, the actual doing stuff. You guys have been sat here for an hour and 15 minutes just listening to me talk, so apologies for that. First off, I thought it would be good to kind of do a little preview of what we're actually going to make. So I've pre-recorded this with me speaking, so I'm going to stop whilst kind of digital online version of me takes over. Hopefully this actually plays. So basically you can see it's a first person level. We've got the kind of mouse movement. We can move with the keys, and it's a little bit difficult to tell on this resolution, but there is actually a cursor in the middle of our screen in kind of typical first person fashion. We've got this kind of sports car on the right side of the screen, which we'll explain in a second. And we've got this field of lava. If you can't tell that's lava, you're obviously wrong because that's very clearly lava that you can walk into. And what happens is when you touch the lava, you die. And we lock your input for a second, just in that kind of typical game fashion, so you don't instantly run into the lava again. And then you get input back, and I can run into the lava again if I choose, and I kind of spawn back at the beginning of the level. So to get over the lava, I need to get into my lava impervious car. If I try and interact with the car initially, I can't do it. It doesn't let me, nothing happens. So I need to pick up my car key, which is on the left on this table over here. I can pick up that car key, I can spin it around, or I can just take it. And if I take it, now I can get into the car. And so with my car, I can safely drive across the lava and I don't die. And I get out again. And I've now passed through a checkpoint. So if I walk back into this lava now, you can see I don't respawn at the beginning of the level. I respawn on the other side of the lava. And then I can just kind of proceed to get to the end of the level. So I go through a trigger here, and you'd hear a very satisfying level completed sound if the audio was working. And as you can see in the top left here, it just prints saying, hey, level is completed. You took 63 seconds to complete this level, and you have no previous playthroughs. So the kind of that's pretty much the full loop of the level, but as you can kind of see was highlighted at the end there, what we've actually accounted for is this level having multiple playthroughs. So if I play through this level very briefly again, I do a slightly quicker job. So I just go up and pick up the car key straight away. I get into my car, I drive across. You can see I've got a level time in the top right. It might be a bit faded, but it is there. And I get to the end of the level again. This time it's saying, oh, I only took 21 seconds, and my previous playthrough took 63 seconds. So we've got the idea we're starting the level again, but we're using our game instance to cache our previous playthrough times, just as a kind of demonstrative way to use all of these things. So this is just a really short loop that uses all of the classes that we've just talked about, controllers, pawns, game instance, game mode. So it's not meant to be, the next AAA VGA winner, but it's just to kind of demonstrate this functionality. So that's kind of what we're going to be doing. let's jump into the engine. So I doubt again that this is available on Box yet, but possibly these files have been uploaded. You don't need to follow along whatsoever. I'm just going to be talking through it anyway. But take a look, and if you see a gameplay framework project up on Box, you can feel free to download that and follow along. But it might just because there were some issues with getting that uploaded, it might not be up there yet. So first off, we're just going to create a level. I'm going to get my notes here on the left, just make sure I'm not missing anything. So first off, we create a new level, which you just go to File, New Level, and I'm just going to make a basic level. This is one that comes with just like some lighting already in it and a little bit of a sky. Straight away, the first thing I'm going to do is make my floor a little bit thinner because I just don't want all that play space. I don't want to be able to kind of drive off the edge because then I just have to make all the collisions much, much larger. And it kind of makes sense that when you're working on a level, the first thing you want to do is save it because, crashes happen even in Unreal. So we'll just call this my gameplay framework folder, and I'm going to call it my map. One thing to highlight here is I'm going to actually be building on top of the Epic templates that you guys actually have. So you'll see in my content, I've got an Epic templates folder like your own templates will have. But what I've done is I've cut out all of the content that doesn't directly apply to this. So normally you would have a lot more folders here for the 5 templates. And even for the templates I'm using, I've deleted a lot of stuff just to make the download a bit smaller. So just if you do download this project and see that, I'll be referencing content that has already been developed by these templates, but some of it I've just trimmed out because I just didn't need it. So I just wanted to highlight that. So if we're creating a new game, it makes sense that we kind of want to make a version of all of these classes. The way I would personally do this is I tend to make a folder called core, and this is to kind of represent. I hadn't even thought about this. This is a workflow I established years ago and hadn't realized that it's basically the gameplay framework classes I'm making whenever I do this, but it is. So we'll make a game mode class. So blueprint, game mode base, BP, my game mode. The BP is typical Unreal naming conventions. The my thing is just to be able to differentiate it. So that's just whatever name you want to call it. But just for kind of like to keep it simple, I'm just going to put my at the beginning of everything. So BP game mode, I'm going to make a player controller, BP my player controller. I'm going to make a character, BP my player character. I'm going to make a game instance, although I won't use this for a while, but just to kind of do it all at once. So game instance, because it's not so commonly used, it's not in the common section. You just need to go down to all classes here and just look for that game instance. And BP my game instance. And lastly, I'm going to make a HUD. So this is that specific HUD class that I was talking about, not the concept of a HUD. So BP my HUD. Okay, so the first thing I'm going to do is, like I said, this builds on top of the existing Epic templates that you guys should hopefully already have access to and already downloaded maybe. And I'm mainly going to be leveraging the walking sim template for a lot of our functionality and a little bit of the vehicle template because you saw the car, right? So that's where the vehicleness is coming from. So what I'm going to do is I'm going to go to my character and I'm going to inherit this character from the walking sim character because it just brings in a bunch of functionality that just makes things a little bit simpler. You can do this there's a couple of ways of doing this. You can just go to any blueprint and just create child blueprint class of this, or you can just make a blueprint and then reparent it, which is what I'm going to do here. So I think it's just called walking sim, player character, walking sim. And you can see it instantly came in with a couple of extra things. And then I'm going to go to my player controller and going to do the same thing. I'm going to go to my class settings and inherit it rather than player controller. I'm going to go walking sim, player controller, walking sim. I could do the same thing with game mode, but I just don't need anything from the walking sim game mode, so I'm not going to do that. Game instance and HUD, I don't need to do those things. So if I go to play now, what we'll see is nothing happens. I've got this kind of floating character, which is not the one I just made, and I can see the things that are getting spawned into the level aren't what I want. And that's because I haven't yet set this level to be using that game mode that I just made. So the way that we do that is via, there's a couple of ways, but the simplest way is this drop down here. You can, this option that says game mode not overridden. So what that means is it's using the default game mode that you specified for your project, which for this project, because I'm building on top of the templates, is this game mode template base. But instead, I want to use this new one that I just made. So override it to be BP my game mode. When you guys download this project as well, you'll see it's already got a finished version of what I'm making. So if you just, if you don't want to follow along, you just want to jump to the end and see what I'm making. Inside the gameplay framework folder, there's another folder called finished, which is just everything I'm about to do in the finished version. And it's all prefaced just with F at the beginning, just to say this is the finished version of that class and that level and whatever, just so you know. So if you see that coming up in AMI dropdowns where it has F at the beginning, that's what that is. So I need to specify the game mode, which I've now done, but if I play, still nothing happens because in my game mode, I haven't set anything up. I haven't set up any information. So I need to go here and say the default character that I want to use is this, the default pawn that I want to use is this character I just made. So BP my player character. And the default player controller that I want to use is this BP my player controller. Okay. And if I play that now I've got something that looks a little bit more like what we had to begin with. So I can move around, I've got mouse, I've got cursor in the middle of the screen. This functionality is stuff that already comes in with the walking sim template. So if you kind of want to understand how this is doing what it's doing already, you can go look at the walking template player character, but just to kind of speed things up, that's not what we're trying to focus on here. So that's why I'm kind of leveraging that. And it's also to give you an example of how you could do this yourselves in your own projects. Just checking my notes here, making sure I'm not missing anything. Yeah. So now to demonstrate the HUD that we're using, again, it's not a class that we would leverage a huge amount, but just to kind of show it working. We can jump into the HUD class. The HUD has a couple of extra things that we can, a couple of extra functions available to it. And we have this draw, I think it's called. Event receive draw HUD. So this is a function that only exists in the HUD class, and this is basically draw something to your screen. Just to kind of demonstrate the HUD working, we've already got a cursor in the middle of the screen, so we don't need that. So we'll put that duration of the level in the top right of the screen. That's what we'll do. So to do that, I actually need to add that timer to my game mode. So I'll do that. I'll go to my game mode class. I'll go to my event graph, and I'll just add a variable here for our time in level, and that'll just be a float. And all I'll do is plus equals for anyone who's not familiar with that kind of code term. It basically says, take whatever value this is and add this to it. So I'm just going to add the time that my last frame took to my time in level, and that'll give me basically my total time in level. And then my HUD, what it's going to do is on begin play, I'm going to get my game mode, get game mode, not get game name, cast it to this new game mode that I made, and I'm just going to hold on to that variable. So promote this to a variable and just say cached game mode. And the reason I'm caching it is just because now every time I want to draw my HUD, I just want to be able to ask the game mode, hey, what's your current time in level? So I'm going to get that value here. I'm just going to do a draw text. And I'm going to draw that. Now, if I play that straight away, I'm going to, I probably want the color to be correct. I'm going to be like that. And I probably want to scale it up a bit so it's a bit bigger. Oh, sorry, that's not red. Now it is. And I'll maybe just indent that. Actually, I'm going to put this in the top right of the screen because that information at the end of the level that says you've completed, this is how long you took, that goes in the top left. So I'm actually going to put this on the right side of my screen. If I play that now, you'll see it's going to be in the top left. Oh, the reason it's not playing is because I actually haven't set that in our game mode yet. So I've made this HUD, it should be drawing, but we're not using that HUD yet. So if I go to my game mode, I just need to go to the defaults and say the HUD class that we should use is this new one I just made. So BP, my HUD. Oh, now if I play, it's in the top left of my screen. But like I said, we want to put that text saying, hey, you completed the level. Here's how long you took up there. So instead, we'll shift it over to the top right side of the screen. So we just do that by get viewport size. This is essentially the size of my screen. Break that and get how wide my screen is. And we're just going to minus some amount from it because if I took the screen size, the text would go off the right side of my screen. So I'm just going to minus some amount from that. Let's say 300 pixels. And that's going to be my X. And I'm just going to put it, I don't know, 19 pixels down from the top. If I do that now, yeah, now it's on the right side of my screen. Not nicely tucked into the edge, but not the end of the world. So you can see that's displaying, and that's because we're now using that HUD, right? We're not going to come back to we don't really need to do anything more with the HUD, but that's just showing how easy it is to put something on our screen and that the HUD class is kind of tied into your game mode. So your game mode is what specifies that. Okay, so we've got this lovely, fantastic play space, but there's nothing going on in it. So what we want is a little bit of danger, right? That's games. People die in games. Not all of them, but some of them, and ours. So we're going to make something that can kill us, which is going to be our amazing lake of lava. So I'm going to make this BP lake of lava. And this is just at the moment an empty actor. One thing that you'll see when you make a new actor is by default, like I said at the beginning of the presentation, actors in Blueprint have to have a scene component as a scene root. I don't think I can, I can't delete that because it needs to have one. But the default scene root of an actor in Unreal comes with this visualization, which can be handy because when I drag it into level, I can see where it is. But once you've dragged in a bunch of those, it becomes quite annoying. So a default workflow of mine is I make a new scene component and I drag that over here, and that becomes the new scene root, and it doesn't come with the visualization because I'm going to put a giant cube of lava on this anyway. So I'll definitely be able to see it. In fact, I don't even need a scene root. The cube itself can be the root component because I don't need to do anything more complicated with this. So I'm just going to do that. So now I've got this cube mesh, but obviously it doesn't look very much like lava right now. So I'm going to specify this is a material that should come from the templates. What's it called? Unlit. There we go, red unlit. That's a bit more lava-y. I'm not gonna get into the weeds about what our lava actually should look like. Red and glowing is enough for me. So if I can just drag that into my scene now, bit roughly there, and I'm just going to scale this. So I can just press R to go into scale mode, and I'll just stretch it across my screen. You can see now why I shrunk the level a bit because I just didn't have to stretch that too far. I'll just make it a bit more treacherous and a bit longer, like that. But it's not going to do anything yet. This is just currently a red cube. It's not saying kill the player, right? I can prove that because I can just walk into it. And currently, by default, it's also blocking collision, right? So I need to change a couple of settings on that. If I go to my cube and I go to my collision settings, I'm just going to change that from block all dynamic to overlap all dynamic. So now it's a bit more like a trigger that you can run into. But now I actually need to make it do some killing. Now, there's kind of ways you could do that by default in Unreal, but we've got a kind of preset way we want to handle health and damage in the templates, which gives us kind of a bit of extra functionality for free. So the way we do that in the templates is we have this idea of health. We have this health component that can do that for us. So if I go to my player character, I can add in health. This doesn't come by default in the walking sim, just because in the walking sim there's no danger that nothing kills you. But now we are going to add in some killing. So I want to add in my health component, and I just need to give my character some health to start with. So I'll set a starting health and a max health of 1. And then I just need to make my lake of lava actually try and find that health and kill me. So if I go down to this cube whilst I've got my cube selected, if I go down here on component begin overlap, what it's going to do is it's going to see if it can search that actor for an interface. This is function. This isn't default Unreal functionality. This is also functionality that comes with the templates, but it's ones that we leverage a lot. We have this concept called interfaces, which is basically a set of functions that get provided. And so when something can take damage in the templates, they use this damageable interface. So we look for this interface, BPI damageable. I see that someone's got their hand raised. Is that something that the TAs will be able to deal with, or should I briefly pause to answer a question?
I can't see any raised hands, Martin.
Okay. It says to me that Salomon has the okay, I'll just keep going then. Maybe that's just like the UI not refreshing or something like that. So I'm looking for this damageable interface, and if it finds one, so
Just
that's to say,
just Martin, because someone said they did raise a hand. If you could slow down a little bit, because you are going quite fast,
okay,
just
yeah,
for people to be able to
hmm
absorb things a little more.
yeah, absolutely.
And just before Martin continues, like just for everyone, this class is going to feel like quite fast and quite a lot to take in. Just take in what you can as you can. And as the fellowship progresses, we'll be able to come back to this as a reference and you'll understand this a lot better. But
Mm,
having this now as a point of reference for you to know that you can come back to will be important down the line. So
yeah,
just try and absorb what you can and don't worry too much if you can't understand everything because we'll have live labs and everything to come back to.
yeah,
So
and
just a heads up for everyone.
I'm around to answer questions. The kind of key thing is just these fundamentals and seeing, the kind of classes that are being used and how you might use them. So the precise setup here is kind of more just a way of showing these things off. Um, so we just want to damage ourselves, damage whatever's walking into it. So we look to see if what's just overlapped us is damageable, and if they are, then we're calling call a function called instant kill. And we do that because lava shouldn't just, in this game, lava doesn't just damage you, we always kill you 100% no matter how much health you have. Because if you have 1,000 health, lava should still kill you. So we use this function called instant kill. So that's the lava will now do the damaging, and I'm just going to say it's the lava doing the damage. Um, but that doesn't necessarily mean anything yet, right? Our health component will say, okay, cool, we've died, but what does that mean? So our character needs to actually do something with that information. So what we've seen in the preview is that we want to kind of respawn back to where we started at the beginning of the level. So the way we do that is we go to our player controller. And what we want to say is when our player controller possesses something, it keeps track of where that thing started and takes that as like, that's the player's respawn point, right? So we're going to add in two variables, B respawn assigned. So this is just so that like if our controller possesses multiple things, it doesn't reset this value every time we do it. It only does it the first time it possesses the first thing. So if respawn is not assigned, then we do this on possess. If respawn is not assigned, then get the transform of the thing that we just possessed and kind of store that as a variable to be like, this was our respawn location, respawn transform really, because it's location, rotation, and scale. Okay. But the other thing that we need to be aware of, and this is something kind of good to be aware of when you're working in Blueprints, is because we've childed this player controller to our walking sim, our walking sim might also have some functionality on possess. And if I quickly go and look at that, it actually does. It does this try bind pawn pickup events on possess. So by default, when you just use that event, it's going to kind of override that functionality. So what we want to do is say, as well as doing this thing, I also want to do whatever my parent class was doing. So we do this call parent function, and we just provide the possess pawn to that. And that just means that when we call this, the first thing that it'll do is go to the parent and do what the parent wanted to do on possess, and then we go on and do what we've said, which is, storing our respawn location. So we go back to our player character. So we're storing this respawn position now. Now we want to bind to our health component and say, hey, health component, when you tell me that I've died, we want to do a few things, right? We want to see if our controller is that my player controller first. So get controller. is the person controlling me a cast to my player controller? Is the thing controlling me this class? And if it is, then we know it's got a respawn location. Now, first thing we're going to do is actually disable our input for a second. Like I said, ignore move input. Just so, again, we're kind of frozen in place for a second. We can kind of take a second to realize that we just died. And then we're going to get our respawn transform that we just set and set to transform to be that. Set us back there. And then we're going to wait. We're going to delay for 1 second before we say we can move again. This is just me being a little bit tidier by using a reroute node so that I've not got lines going through my nodes here. And the last thing that we need to do is the way the health component works is you can only die once, just so we're not firing died functionality loads and loads of times when we only want it to happen once. So because we've essentially revived now, we've respawned, we need to let our health component know that we've done that just so we can die again. So we're just going to say revive on that. And the revive source was we've revived ourselves. And we want the revive behavior to just be put us back at full health. That's fine. Okay, so if we test that, we see that now respawns us back at the beginning of the level. And I need to untick that. Yeah, I was locked in place because I didn't untick that ball because I copy pasted. I'm locked for a second and now I can move again and I die. Great. So now we need a way to get over this lava, which is our car. So let's make that.
Just a quick heads up, when you're making the blueprints, just in terms of the UI of the blueprint, if you could hide the compiler results or at least make it smaller so that people can see the blueprint a little bit better.
Yep, absolutely. Yeah. So we're going to make our car blueprint so we can drive over this lava. Again, there's a couple of ways I could do this, but I'm just going to make an actor and call it BP my car. And I'm just going to inherit it. Now, in the templates, there are 2 cars that you can inherit from. There's sports car and there's advanced vehicle, I think. I'm going to inherit from an advanced vehicle because the sports car comes with a lot of functionality specific to like being in a race, which we just don't need here. So I'm going to do that. And then I just need to specify that this thing is using the car mesh because at the moment it's invisible. If I look at the viewport, you can see nothing. So I just need to assign the car. It's going to look like the sports car. Okay, let me just catch up with my notes. Okay, I'm just going to drag that car into the level. Okay, so my car exists, but I can't do anything with it yet. I need to be able to like click on it to get into it. But first, I want to make sure that I need my key to get into my car to kind of experience that flow of having a pickup. So we're going to make a pickup. We're going to make a key for our car. First thing I'm going to do is make a pedestal that our key can go on. So I can just go to add shapes and a cylinder. I'm just going to put that there. And our key is just going to go on that. And then I'm going to make our actual key class. BP car keys. So with the car keys, again, to just get a lot of that pickup functionality, we can leverage some of the stuff that's already done for us in templates. We can just child this to a class we've already made called static pickup. And by doing that, it just instantly means our character can already pick it up. It's already, all that functionality is done for us. I just need to worry about any extra stuff that it does and the way it looks, because currently it's just a giant 1 meter by 1 meter by 1 meter cube. So I'm just going to make it a little bit thinner, a little bit less wide, and taller than the other 2, but still pretty small. Okay, so it's a small cube like that, or a cuboid. And I'm just going to give it a material. So if I just look for key, this is a material that's just in the engine already, and it's called key, so I thought I would just use that. So this is our key pickup to get into our car. Just going to put that there. and just make it lie down so it's a bit more believable. And we can see, like I said, because this inherits from that pickup class, I can already pick it up, right? Um, to make it so that it's a pickup I can take, which is important, I just need to go to this. Again, this is functionality that comes from it inheriting from this static pickup base. But I just need to go to this to my interfaces for this pickup. And if I go update can be, oh, not update can be taken. I just need to tick this to basically say this is a pickup that can be taken. And now when I go to it, get there, and you can see I've now got a take button and I can take it by pressing E. So I've got my key, I can get into my car, but I actually need to make that functionality on the car now. I still, the car, we haven't set anything up to be like when I click on the car, I can get into it. So if I'm going to make my car an interactable that my player can interact with, the easiest way to do that is using another interface that already comes with the templates, and that's this. If I go to class settings on my BP car, implement interfaces, and I'm going to go BPI first person. Oh, keep typo. First person interactable. And this is basically a set of functions that says this thing can be interacted with by the walking sim player. And the only thing I really need to worry about is the text that comes up when I hover over it. So I'm just going to go to this get interact text function and type in car. I don't even need to do that. It's just a bit nicer. And then I'm going to say like what happens when we interact with this car. So if I just interact start here, there we go. And what I'm going to do is I'm going to make a function for this, and I'll explain why I'm turning this into a function in a second. But I'm going to call it handle interact start, and it's going to take in a controller. Or is it? No, it's a controller. So interact start basically passes in who is doing the interacting. So our handle interact start, we just want to pass that information through interacting controller. And so when our car is getting interacted with, the questions we want to ask is, am I already being controlled by someone? Because someone shouldn't be able to hijack me, right? So we'll say get controller, and if controller is not valid, so if I don't have a controller, then I can do the rest of the stuff, right? So next thing I want to say is, okay, so I'm being interacted with by someone, but I don't want them to get into this car unless they have the car key. So I go to the controller's pawn, so the thing that the controller is currently controlling, and I ask it, do you have an inventory first? Well, first thing I'm going to do is actually cast that into a variable. Say like, here's the old pawn that that controller was controlling. And if that is valid, so if the controller actually is controlling a pawn, it hypothetically could not be, right? So if there is actually a pawn there, then we're going to do the rest of this stuff, which is we're going to say search actor for interface, and we're going to look for an inventory, which is again something that comes in through the templates. We have this simple inventory interface. And we're going to say if they do have an inventory, then we're just going to ask them, does contain item by class. So do you have a car key? And if you do have a car key, then you can get into the car. Okay. And what that looks like is getting this interacting controller, and we just say, in fact, I can just do this, get interacting controller, and we just say possess this car. Instead of what you were possessing before, we're now going to possess me, essentially, this car. And now you control me. But I'll show you what happens here. If I give my character a mesh. Okay. because our car is a pawn and we've dragged it into the level, by default, what Unreal does is say, okay, if something's been dragged in, I'm going to automatically assume it's an AI that's meant to have a controller. So you need to change this setting to say, when this is dragged into the level, don't automatically try and give it an AI controller. So the car wasn't letting me into it because it was saying, oh, I'm already controlled by an AI. That goes there. And now you can see I'm interacting with the car. But you can see the guy I was playing as is hovering around in the air, which isn't what we want, right? So we want the car to kind of clean up the person who's meant to be driving us. So we're going to say, okay, this all pawn, the thing that the controller was possessing before, which was our character, we're going to set that as a variable. And that's going to now be our driver. And we're going to say, okay, now that driver is going to be hidden. We don't want to see them temporarily. We don't want their collision to be on because we don't want to drive into something invisible. And lastly, if it's a character, they will have a character movement component, and that will have gravity on it. So if we turn off their collision, they'll just fall through the floor forever, and we might get bugs. So what we're going to do is we're going to search that character for their character movement component. By class. Character movement component. Promote that to a local variable. And if they have one, so this will be null if they didn't have one, it'll be not null if they do. If they have one, then we're just going to turn gravity off on it. So gravity scale to 0, just so they don't fall through the floor. Okay. And now, when we get into a car, oh, pick up the key. Oh, I think I'm in my own position there. That's really annoying. Just going to turn off the collision on see the guy's not hanging around anymore, so we can kind of pretend he's inside the car. But my car can't move yet. That's because my car is using a set of inputs that are kind of car specific, so it's listening for like throttle and brake, but the game isn't using those at the moment. So what we need to say is temporarily, whilst we're using this car, we want to use this new set of inputs, this kind of car set of inputs. So we're going to go to our car. And we're going to go to when this car gets possessed, we're going to see if the thing possessing us is a player controller. So it has to be a player controller. Because obviously only player controllers have input buttons, right? AI doesn't need buttons. And we're going to do get enhanced input system. And we're going to do something called adding a mapping context. A mapping context is essentially a set of controls. So there's one for the vehicle, there's one for the platformer. It just means that in your game you can say, don't use these controls until a specific time, and then you don't have to worry about accidentally what happens if they try and use the brake button whilst they're the first person jumping around. You can say, none of these controls exist until this time. We're going to add the vehicle buttons when we get possessed, and when we get unpossessed, so when we're no longer being controlled, the person who was controlling us, we're going to say, stop using these inputs. Don't listen to the vehicle inputs anymore. But it's remove mapping context now. Again, our mapping context is the vehicle. Okay. So we jump to our car now. And need the key again. Keep forgetting that. Jump into my car and now I can drive. So we've made this button now, but we need to add that to our mapping context. Like I said, our set of controls that occur when we're in the vehicle. So if I look for IMC vehicle, this is one that was already made from the vehicle template, and you can see it's got throttle, brake, handbrake, toggle camera, all these kinds of things. Oh, I accidentally already had it in. But yeah, these are the controls that you would see, and we're going to instead add this new one that we just made, IA leave. You see there's two because that was the finished version, FIA, but we're going to add IA leave. Okay, so now that's a button that occurs in this input set, but we still need to say, well, what button triggers that event? So I'm just going to say F. So I press F to fire this event logic, this leave logic. But my car currently doesn't do anything with that yet. So I'm going to go back to my car blueprint and say, when we do IA leave, when we press that button, what do we do? We're going to essentially spawn our driver back next to us and repossess our driver, right? So that it looks like we've gotten out of the car and we're controlling it again now. We've already held on to a reference to our driver, so what we're going to do is say, if we have a driver, maybe just catch a situation where we're somehow able to press that button, we don't have one. If we have a driver, set their transform to be wherever our transform is, so our car's location, because our driver has just, they're invisible and their collision's turned off, but they basically just stayed wherever they were, so we need to teleport them now. And we're going to teleport them to be our location with a slight offset. And make variable here, and this is going to be a local leave offset. And I can just edit the default values here. I'm just going to say we just get out of the car on the left. I don't know if that's American or English right now, but I'm just going to say we get out 1.5 meters to the left, and that's going to be where we set. And if you remember, we turned off their collision, we made them invisible, so we need to undo all that stuff. So we're going to get our driver pawn, and we're going to set actor hidden, and make them not hidden anymore. We need to enable collision. And if they have a movement component, we want to turn their gravity back on. Okay. Play that. Pick up the key this time. Take it. Go to my car. Hit it. Drive across. I press F now. Pick it back up. Oh, but I haven't done the possessing. So we put our driver back out of the car. We actually haven't done the last thing that we need to do, which is actually say, hey, now control the driver. So last thing we do is just get our controller and tell it to now stop possessing us and possess the driver instead. The other side. Okay, cool. So we've got over the threat, but now that we've gone all this way, we have to work out to get the key, get into the car. We want to basically not have to go back to the beginning of the level when we die, right? Oh, I think that was, I know why that was happening. That looked like the checkpoint was working, but it actually wasn't. We forgot in our controller to say only set that value the first time. be over at this point. There's not much left that we need to go through, but my intention would be just to keep going for a bit, as long as that's okay. I'm just going to keep going unless I hear like any voices of complaint. Oh, okay, you go quick. So we need to make a checkpoint. Now again, we've already got this value for where we respawn to, so really all we need to do is have something that says when you enter this area, update that value. So we're just going to make an action, call it checkpoint. And we're going to add a box collision, which is a bit like a just a collision that you can't see because you don't need to. And we're just going to say when you overlap this, when this actor gets overlapped, we're going to cast it to see whether it's what's overlapped us was a pawn. If it's a pawn, then we can get its controller. And if we can get its controller, we can see if that controller is a my player controller. And if we can do that, then we can set our so what we want to do is basically like be able to drag the checkpoint in and say, hey, when you go through this checkpoint, this location is going to be where you respawn at. So I'm just going to make a actor reference here, respawn actor. I'm going to make that public so we can change it in editor. I'm just going to get whatever that we just chose and get its actor transform, and that's going to be our new respawn location. So I just need to put that checkpoint into the level, and just scale that up so it's in the section here. And then we actually need to say, hey, where do you respawn? So we're going to add in just kind of blank empty actor to act as our, like, what is the actual respawn point. I'm just going to slightly so it's less like the card is in it. And then you can see we can, now that I've made that actor variable public, it's appearing here, and I can just choose what I want. So I'm going to eyedrop this one here. I'm just going to call that respawn actor to make it clear. Okay, so pick up the key, drive through, get out. I've gone into the trigger now, hopefully. Yep, you can see I'm now respawning back next to my car rather than the beginning of the level. So now we've got a kind of full loop in there. All we want to do is really be able to finish the level. So we're going to add in, just to make it so I can't drive straight to the end of the level, I need to walk there. I'm just going to add in 2 little cubes to act as doors. Shape. I'm just going to make that a bit thinner and a lot wider, a bit taller. And you can just press end to snap any kind of collision just down to the floor. That's a handy little shortcut. So that looks thin enough that my car couldn't get through it. And so the last thing I want to do is basically say, I'm going to put a trigger at the end of my level, and that's how we know we've finished the level. And this is, we're going to use a level blueprint now. And so a really easy way to interact with level blueprint and triggers is rather than having to make a blueprint, a bespoke one, we can just use a trigger volume. So if you go to add volumes, and I just go to trigger volume here, I'm just going to size this up. Quickly go to brush settings, and yeah, I was just there. I'm just going to make it super wide, so we always overlap it. And I'm going to go to my level blueprint, which you access up here. Press these buttons and then click on level blueprint. And like I said, in the level blueprint, you can access any actor that's in the world. The way you do that is you just right click, and you see this in the context sensitive section. The option here comes up, create a reference to the trigger volume. But as well as that, you can automatically attach to any event dispatchers, which are kind of delegates for anyone who's familiar with code, any delegates that actor already has. And trigger volumes have a couple of delegates already, event dispatchers already assigned for when they get overlapped. So really easy to just say, hey, when someone overlaps this trigger volume, Let's see if it's a pawn, just because, we don't want a bullet to overlap this and think it's the end of the level. And we'll see if that pawn is player controlled. If that pawn is player controlled, then game over, right? We're just going to say we're going to wait a couple of seconds. And what we're going to do is restart the level. So we get our current level name and open level. It's a really quick, easy way to do this. Get the current level name, open that level, and our level will restart. And I'm also just going to play a sound so we know that it's happened. So I'm just going to do play sound 2D. And I'm just going to use a sound from the engine. I happen to already remember the name of, called compile success, because it's vaguely successful sounding. Pick up my key, drive across, get out of the car, walk through the doors. I've finished my level, hear the sound, and after a few seconds, level restarts. So that's the full flow. That's using all of the classes we kind of wanted to go into. But if we just wanted to, the kind of one concept that we currently haven't used is this game instance where we're caching how long a level took. So I'll just take a couple of minutes to do that. It'll only, shouldn't be long, but it's also the key things have already been leveraged here. The main thing we need to focus on was this kind of possessing, controlling different pawns. So we've already got our game instance. All we need to do is basically have some way to hold on to like our previous playthrough times. So I'm going to just go to our game instance and just add an array of floats. It's basically like level playthroughs. And every time we finish the level, all we're going to do is say, hey, I finished the level, print some text, and add my playthrough time to that. Now, because the level time is already being handled in our game mode, it makes sense to do that here rather than having to grab the information from the game mode. So I'm going to make a custom event called level complete. And I'm going to have a bool that says be level complete, and I'm going to set that to true. And the reason I'm doing that is just so our time doesn't keep ticking up for those 4 seconds where the level hasn't actually, where we finished the level, but it's not over yet. We've not reset. So I'm going to set level complete to true. And if that's true, if that's not true, we keep ticking up the time. Okay. So now when we complete our level, we won't see the time keep going up for those last 4 seconds. I'm going to turn this into a function before make this a little bit simpler. Handle level complete. That's just a standard thing that I tend to call functions that basically exist next to the event. And in here, we're just going to print string, say, we're going to basically compose a string that is what's the text we display at the end of the level. So I'm going to create a local variable for this function, just called finished text. It's going to be a string. And initially, all it's going to say is level complete. Then what I'm going to do is I'm going to get my game instance and see if it's set to our special new game instance that we've made with this playthrough times. Yeah, and get. So we're going to do a couple of different things. But last thing that I'm going to go last first, we want to make sure that with every playthrough, we're adding our current playthrough time to that cache. So we're going to go to playthrough times. Oh, sorry, if I casted the wrong one. Yeah, cast to my game instance. Level playthroughs. Get level playthroughs, and we're going to add our current playthrough time. Okay. But before that, we want to kind of print our string to say, here's what your playthrough time was, and here's your previous ones. So if our playthroughs length is 0, so we have no previous playthroughs, we're going to say if it's greater than 0, Then we're going to add to our finished text. We're going to say append. You have no previous playthroughs. Thoughts. I'm going to add that there. If we do have one, then we're just going to quickly loop through that. Each and append. We're just going to append what our playthrough time was that time. And just before that, we're going to say your playthrough time was. And what our current time was. And we've added all of the other ones. Just trying to make sure I haven't missed anything. Yeah, you have previous playthroughs I want to add here. So basically, I'm just like adding bits to this one bit of text that I'm now going to print once at the end. And you'll notice I keep putting lines down so that you can kind of, it's not all going to get munged together into one long line of text. Okay, and then the last thing I need to do is actually print that string that we just made. So print string, that, I just call this function. So handle level complete. Then I go to my, wherever my level blueprint is, and we've done this playing sound. We're just going to get our game mode, make sure, I'm doing a sequence here because it's like, I'm going to cast my game mode to see if it is of the type my game mode, but I don't want the rest of the logic not to fire even if it isn't. So that you use a sequence to kind of say, do this either way. Do this and then always do this regardless of whether or not this failed or succeeded or whatever. So I'm just going to call level complete. And I think that should be it. So take the key, drive through, get out the car, walk through. Oh, it's not printing. Give me 1 second.
I think you need to call handle level complete.
Does it not do that already? My game mode. Got too many blueprints open here. There we go. It does call it handle level complete. Da, da, da. Ah, I know why this is happening. So we've set all of that stuff up. The thing that we haven't done is we haven't said we want this game to use that game instance class that we made. So we need to go to our project settings and set that. So edit project settings, and this is where you specify the one game instance that your class uses. So BP my game instance. Otherwise, that cast wasn't working, so the rest of the logic wasn't firing. There you go. Your playthrough time was 10 seconds. You have no previous playthroughs. And if I play again, it's very quick. I can make, obviously, that print string and last a little bit longer, but just for the sake of saving a bit of time. Your playthroughs were 10 seconds. Your playthrough time was 9. So as you can see, we're replaying the same level. The same game mode is getting used. We're respawning all these things. It's essentially like we're opening the level for the first time just again. But by using the game instance and storing those variables there, because the game instance isn't despawned on every level, even though we're reloading the level, all the information it has in it persists throughout your play session. So if I go to my game instance, we can see that that's just this array of floats. Important to highlight that the game instance is now gone now that I've stopped playing. So if I now play again, it's not going to hold on to my playthrough times now. They're going to be back to empty. And that's like just part of the way the system works. If I wanted to store stuff between playthroughs, between the actually opening the game, then I would need to do that through save files. So that's everything. We've used all the classes there. We had controllers possessing things. We possess multiple pawns. We jump from the driver into the car, back to the driver. We use the game mode to store our time. We use the player controller to store our respawn location. And then we adjusted that through our checkpoint. We called back to that when our character died. We used the health component and damaging to kind of show how we might do that through the templates. We had interactability with the pickups. You made the car interactable so you can click on it to jump into it. And we used the level blueprint for level triggers, such as like reaching the end of the level, and finally displaying some information. And then last of all, we had the game instance, which is keeping track of our playthrough times from multiple levels so that when we reload that level, we don't lose all that information. So that's everything in the gameplay framework. Apologies for the kind of lightning pace at the end there, but I'm already 17 minutes over, so I had to kind of rush a little bit there. Yeah, I think that's everything.
Thanks, Martin. I think we're gonna have I think probably a 10-minute break because we did go through quite a lot. And I
Yeah.
think people need a bit of a reset.
Yep.
So what we'll be doing is we'll reconvene at 1/2 past the hour, and then we'll have the lab, which will only last half an hour in this case, so you guys can ask questions to Martin directly
hmm
um, in the other call. So let's reconvene at 1/2 past the hour. We'll be using the link to the course lab with the TAs. So please make sure you use that Zoom link inside your Unreal Academy, and we can go from there.
Yeah. Amazing. Thank you very much. And yeah, I hope you can decompress properly in those 10 minutes.